Hi, I'm Eric, Vice President of Technology here at Lynn Associates. We would like to welcome you and thank you for taking the time to watch the Lynn Associates ALTIUS High Performance HMI Solution product overview. The general purpose of this presentation is to get you familiar with the benefits and features that we have developed over the years by merging industry best practices and client feedback to create what we feel is a complete solution. Structured around the concept of situational awareness, ALTIUS is essentially a proactive approach to HMI design. With increased control and customization, you are fully aware of and therefore responsive to every stage of the process environment and the intended outcome. The overarching goal of ALTIUS is to provide operators with a comfortable, intuitive work environment. John is now going to take us through all the details, starting with the layout of our environment. So let's get started.
Thank you, Eric. Now, the typical setup consists of 2 or 4 screens, as you can see here. The main section of each screen contains an HMI process display that has been built to a standard 4:3 square ratio. Now, this space to the right is reserved for the faceplates within the process display. And at the top are the navigation menu, loop watch, and DAT ribbon. To the left are a set of tools which we call widgets that are part of our widescreen solution. Now, these items will be discussed individually later on. Now, there are a number of HMI display types. The industry refers to them as levels, and they generally run from 1 to 4. Level 1 displays are console overviews comprised of qualitative style shapes and are designated for large screen displays. Level 2 displays are unit overviews. Level 3 are process displays for the majority of operator control, and Level 4 are equipment details.
So the idea here, with all these components combined and using a 2 or 4 screen setup, is to give you a more complete control interface. So let's now take a closer look at some of these components.
As we all know, navigation is an essential element on your HMI. And we can all agree that valuable time is wasted when navigation is cumbersome and unintuitive. Now, that's why we designed the 3-tier navigation menu. This menu provides quick access to the Level 2, Level 3, and Level 4 HMI process displays discussed earlier. A display can be invoked by clicking a button or by dragging and dropping to the screen you'd like. Now, this menu also uses the inherent system alarm settings and alarm groupings to guide you to any alarmed point. As you can see here, the Level 2 shows a flashing arrow indicating an alarm on a lower level display. Now, the lower level that contains the alarm shows the entire button filled with the alarm color. Additionally, a tabbed menu shape can be embedded on each HMI display that contains identical functionality at a single tiered level. You can also open programs and documents and if access is needed to another console's HMI displays, you can toggle between multiple menus. With the Advanced Graphic Library, our intent is to enable more efficient plant operations and improved situation awareness. Let's take a moment to look at the AGL shape libraries to briefly discuss their benefits. As you can see here, there's a predominant grayscale scheme with limited color use to allow important status variations to better stand out. These tones are all customizable through style sheets, so you can alter your coloring convention to better suit your environment. Our AGL is comprised of all the standard shape libraries, including CDA, TPS, SCADA, Fieldbus, and we even offer dashboard and SIS libraries. I'll touch on the dashboard library a little more later. As for the SIS library, These shapes are specifically constructed to show safety system logic, so you can easily trace the source of any trip. All the shapes in these libraries are also designed to display information in a variety of ways. You can simply roll over a shape, as I just did with this controller here, and our tooltip appears, showing some useful point details. Or you can use this group of buttons in the upper right to change exactly what information is shown on the HMI display. Now, for instance, the first buttons allow you to toggle on and off tags. You can show set points on your controllers or display engineering units. Now, the next button switches shapes between an analog numerical readout to our qualitative view, commonly referred to as bar mode. We'll go into more detail later about just how important the qualitative view is. The next icon increases or decreases all parameter values, so that, say, a supervisor can monitor a point for you from a few paces back, eliminating his need to hover over your shoulder. And finally, the last buttons allow you to quickly acknowledge or silence alarms per page. Now let's move on to the right portion of the screen. We're all familiar with the standard Honeywell faceplate that displays here when you click a shape. Well, we've decided to add on a feature we call the faceplate enhancement, such as this simple trend. Optionally, you can display the hourly averages enhancement. These settings can be configured from the DAT ribbon as well as disabled entirely. And now we move on to our right-click menu. Now, we're all familiar with the standard options available. Now, we went ahead and added some robust functionality, which we will review starting with the Alarm Informant. The Alarm Informant provides a direct link to the Honeywell Alarm Configuration Manager, or ACM database, allowing you to now view details on alarm limits, cause and effect of alarms, and how to safely and effectively manage alarm scenarios right from the HMI process display. Next is the Operator Guide, which is essentially a user document containing specific information and procedures for the selected point. If you'll remember, I mentioned earlier I'd touch back on our qualitative view and its significance in rapidly parsing information. Well, this next feature lets you set the operating limits for this view. On the pop-up, you can enter your desired limits or apply default limits, and even take a quick peek at the alarm limits. Then, simply click Save and Close. And now, this is how qualitative view works. Each point value is indicated as an arrow on a scale between the low limit and the high limit. If the point's value exceeds either limit, the shape will automatically switch back to a number. For instance, these few indicators at the bottom here. So, when making a cursory scan through a number of displays, this bar indication, or qualitative view, makes it quicker and easier to notice what area needs some attention. The next LNA right-click feature is the Mini Trend, which is basically an ad hoc trend with the primary changeable features being ranges, trend scales, time base, and reference lines. For more in-depth trending capabilities, we have the Trend Builder, which serves as your scratch trend. With drag-and-drop capabilities, you can build your own trend that can be saved for future reference. We've enhanced the standard system trend configuration, allowing you to more quickly and efficiently build trends. After adding the necessary points, you can apply filters, clear trend, or remove unchecked points. Then select a system trend by title, merge the trends together, and finally save to the system. Next, we have the Averages pop-up display that shows 6-minute, 1 hour, 8-hour, and 24-hour averages, as well as 5 and 60-second history snapshots. Now, this next feature works with primary and secondary controllers in a cascade loop. As you can see here, both points are in manual mode. Now, it usually takes multiple clicks to change them back to their respective modes, but with Close Cascade, you can put both controllers back into their normal modes with just one click. And finally, the last of our added features is the ramp option. This lets you enter a target set point value and ramp time or ramp rate. Then, simply click the Start Ramp button. So, as you can see, these added right-click menu features literally give you more control and options at your fingertips. Now, let us revisit the dashboard library which I previously mentioned. Now, typically, the HMI displays incorporating these shapes will be on large wall-mounted monitors, giving you an overall view of the process health. The idea is to use pattern recognition to establish situational awareness for a more proactive approach. As you can see, a quick glance at the dashboard lets you know if everything is operating normally. In this example here, all the icons are on the line, so the unit's health is good. If undesired changes are made, our process is affected, and you can see these effects as the icons move away from the center line and get darker. Now we know what area to be concerned with and can then diagnose the issues on our console. These large screen displays can be very useful for collaboration and communication. Neighboring units either upstream or downstream can recognize deviations or other abnormalities and can prepare their unit or offer assistance. Working together as a full plant team seems a better way to handle potential issues rather than just waiting for alarms. Now let's move on to the Loop Watch Monitor, an additional standalone application enabling you to keep watch on critical process variables. Now first, add a point to Loop Watch by simply grabbing a shape and dropping it right in. By clicking on the point, a trend appears below with customizable ranges and boundaries. These boundaries are key because you can simply move the lines up or down to set them as desired limits. Now, watch as Loop Watch runs some predictions for us. Using a linear regression equation, it calculates where this PV will be in the next 5 minutes, or basically a quarter of the full trend time. The white line on this prediction trend shows the end results if the value continues in this way. Here you can see that the PV is being projected to be above the upper boundary in the next 5 minutes. When the value is predicted like this, a hollow arrow will appear next to the value. If the value has already exceeded, then a solid-filled arrow will appear. If the arrow is not enough, you have the additional option of enabling a message log for these boundary indicators. Now, let's take a look at this area to the right of Loop Watch. This is the DAT ribbon, which stands for Dockable Applications and Tools. And it's where you'll find Limit Watch, a useful tool for keeping an eye on process health by monitoring all these defined operating limits. A common question we hear is, how do I see when a process value is outside its limits if that particular HMI display is not on my screen? A very valid question. Now, Limit Watch can help you with that. Let's add a display to Limit Watch by right-clicking on the menu and selecting Add to Limit Watch. It will now monitor all the points on that HMI display, notifying you when one or more points exceed their operating limits. With icons integrated into the menu, you're guided right to any areas of concern. For instance, you can see that this icon here is gray, telling us that all values on the display are within limits. But we can see that this icon right here is black. When we go to this display, we see that there are a couple of points outside the limits indicated by the numbers. Now, let's move to the left of the screen and discuss our widgets. Widgets came about as additional accessories to fill the increased space now available with widescreen monitors. Instead of stretching the HMI process display, we thought the space could be better utilized with additional tools. Just drag and drop whichever point you want right onto the widget. With widgets tied to an HMI process display, specific point configurations can be saved and revisited in the future. Now, let's take a closer look at the widgets we offer and just what they do. The Group widget can display 4 or 9 individual points monitoring set point, PV, output, and mode, with certain editing capabilities similar to the faceplate. The Trend widget can trend PV data for up to 4 points with time spans of 20 minutes, 1 hour, 2 hours, 8 hours, 24 hours, or 96 hours. Next, the Dashboard widget can track up to 8 points for any temperature, pressure, flow, level, or analyzer deviation. As the icons drift away from the normal baseline, as you see here, they darken in color, indicating the severity of the deviation. The Event Analyzer widget provides a quick summary of events in the past 5 to 20 minutes. It queries the event summary log and categorizes them by active alarms, acknowledged alarms, return to normal, mode changes, set point changes, or output changes. By clicking on these quick, handy icons, you can see a list of what has happened in that specific time interval. Now, this tool is extremely helpful for any time you need to step away from your console. Finally, the Operator Notes widget is essentially a running log for operations to communicate with each other, management, and engineering. Just like the Event Analyzer widget, this widget is also really handy during shift changes, or say when a unit is down for maintenance, if something was bypassed in the night, or for whatever other possible details you think are worth recording and sharing. Now thus, as you can see, we designed these widgets to provide you with useful, more in-depth information readily available on an HMI display.
Thank you, John. So that wraps up our overview of the entire ALTIUS high-performance HMI solution. As you can see, we really focused on building this suite to be a more proactive approach, focusing on establishing solid situational awareness while also giving you, the user, the ability to personalize your work environment for maximum productivity, efficiency, and accuracy. While this demonstration illustrates the features within the Honeywell Experian DCS format, Lynn Associates has developed many of these features on other DCS platforms. If you have any further questions or are interested in seeing more, please do not hesitate to contact us. Thank you again for watching this video.